Good afternoon, students. Welcome to the session on boiler corrosion. What is boiler corrosion? It is the decay or disintegration of boiler material due to chemical reaction with the environment. And it is a serious problem which arises due to the use of unsuitable water in boilers. So boiler corrosion, it can be defined as the process of degradation of boiler surface due to attack of boiler feed water. And boiler corrosion, it will shorten the life of boilers and it can also cause leakage in joints of the boilers. Now let us see the causes of boiler corrosion. First one is presence of dissolved oxygen. Second is presence of dissolved carbon dioxide. Third is acid formation due to hydrolysis. And fourth one is presence of free acids. Now let us see how the presence of dissolved oxygen can lead to corrosion in boilers. Dissolved oxygen, it is present in boiler feed water. This dissolved oxygen, it will combine with water as well as iron, that is the metal with which boiler is made up of. Okay, so iron, it will combine with water as well as dissolved oxygen and forms the corresponding hydroxide, that is ferrous hydroxide. This ferrous hydroxide, again it will combine with dissolved oxygen and form hydrated ferric oxide. Here iron, it is in the +3 oxidation state, therefore it is ferric oxide. Since two water molecules are attached to this, it is called hydrated ferric oxide. This hydrated ferric oxide is nothing but rust. So this is how dissolved oxygen lead to the formation of rust in boilers, or this is how dissolved oxygen lead to corrosion in boilers. Now let us see how dissolved carbon dioxide can lead to corrosion in boilers. Now carbon dioxide, it will be present in the boiler water either from air or due to the presence of residual temporary hardness. Temporary hardness means the temporary hardness, it is caused due to the presence of carbonates or bicarbonates of calcium and magnesium. That means the water will have calcium carbonate or magnesium carbonate or calcium bicarbonate and magnesium bicarbonate present in it. Okay, because temporary hardness, it is due to the presence of carbonates and bicarbonates of calcium and magnesium. Now, carbon dioxide, it will be present in water because carbon dioxide in the atmosphere, it will be carried out by rainwater, and this gas, it will be present in the dissolved state in rainwater. Okay, so all natural waters, they will have carbon dioxide, oxygen, oxides of sulfur, oxides of nitrogen, etc. present in them as dissolved gases. Okay, so the calcium bicarbonate that is present in water, it will decompose upon heating to calcium carbonate, carbon dioxide and water. This carbon dioxide, it will dissolve in water to produce carbonic acid, and carbonic acid, it is a slightly acidic in nature and therefore it can lead to corrosion. So this is how carbon dioxide can lead to the formation, can lead to corrosion in boilers. Now presence of magnesium compounds. Acid may be formed due to the presence of magnesium compounds in boiler fed water, which results in the drop of pH. Because if magnesium chloride is present, magnesium chloride, it can react with water at higher temperatures. What happens? Magnesium compound, they get hydrolyzed to form the corresponding hydroxide, that is magnesium hydroxide, along with hydrochloric acid. Since acid is formed, pH will be reduced, and this resultant acid, it can attack the boiler to form rust. Because the acid thus produced, it will combine with iron to form ferrous chloride, FeCl2 and hydrogen. This ferrous chloride, again it will combine with water and get converted to corresponding hydroxide, that is FeOH twice, and again HCl will be released. This ferrous hydroxide, again it combine with oxygen and form hydrated ferric oxide, that is rust. So this is how magnesium compounds present in boiler fed water, it can lead to the formation of rust and thus leading to boiler corrosion. Now, how to control boiler corrosion? Boiler corrosion, it can be controlled by reducing the quantity of oxygen, carbon dioxide and any acid from boiler fed water. Now, how can we remove these gases, oxygen, carbon dioxide and acid present in boiler fed water? How they can be removed? First, we'll see oxygen removal. Oxygen present, it can be chemically removed by using hydrazine or sodium sulfite. Okay, when you treat the boiler fed water with sodium sulfite, what happens? Sodium sulfite, it will combine with oxygen and gets converted to the corresponding sulfate, that is sodium sulfate. Thus, the amount of dissolved oxygen in the boiler fed water, it can be removed or it can be reduced to a considerable extent. Now, carbon dioxide removal. So, carbon dioxide, it can be chemically removed by treating with lime or ammonium hydroxide. Okay, lime, it is nothing but calcium hydroxide. So, when the water, when it is treated with calcium hydroxide, what happens? Carbon dioxide, it will get converted to the corresponding carbonate, that is calcium carbonate, and thus the amount of carbon dioxide in the water, it can be reduced. Now, third one is acid removal. The acid impurities that are present in the boiler fed water, they can be removed by adding base, that is either sodium hydroxide or potassium hydroxide can be added. So, what happens when a base is added? The acid formed, it will react with the base to form the corresponding salt, and thus it will be neutralized and removed. So, this is how we can remove or reduce the amount of dissolved gases like oxygen and carbon dioxide as well as the acids that are present in boiler fed water so as to reduce corrosion. Now, next is biological oxygen demand. What do you mean by biological oxygen demand? The amount of oxygen that is required for the oxidation of biologically oxidizable compounds present in 1 liter of wastewater over a period of 5 days at 20 degrees Celsius. That is known as biological oxygen demand. Clear? The amount of oxygen that is required for the oxidation of biologically oxidizable compounds or impurities present in 1 liter of wastewater over a period of 5 days at 20 degrees Celsius. That is known as biological oxygen demand. Now, the dissolved oxygen in water, it can be determined by Winklers method. By this method, we can determine the amount of dissolved oxygen in a definite amount of water. Okay. Let DO1 be the dissolved oxygen of the sample in milligram per ml at the start of the experiment. That is, on first day of the experiment, let the dissolved oxygen amount, let it be represented as DO1. Okay. Now, after 5 days, again we will measure the dissolved oxygen level. So, that time, let the dissolved oxygen level, let it be represented as DO2. Okay, whether DO2 will be less or high. DO2, it will be obviously lesser than DO1 because the impurities that is present in the sample, they will use up the dissolved oxygen present in it for the oxidation. Okay, so definitely DO2 value, it will be less than DO1 value. So biological oxygen demand, it can be calculated as dissolved oxygen level on first day minus dissolved oxygen level after 5 days, that is represented as DO2. So DO1 minus DO2 will give you the amount of dissolved oxygen that has been used up by the impurities for oxidation, and BOD it is expressed in milligram of oxygen per liter. Okay, so this much milligram of oxygen, dissolved oxygen, it will be used up by the oxidizable impurities present in 1 liter under aerobic conditions. Okay, so that's all for today's class. Thank you.